Hi, it is April Fool's Day, Wednesday, April 1st. Um, I'm going to go over the Free Response 2017 question number 2, which says, I'm sorry if I'm jiggling this thing around, but all right. Manager of a local fast food restaurant is concerned about customers who ask for a water cup when placing an order, but fill the cup with a soft drink. Oh my goodness, from the beverage fountain instead of filling the cup with water. I hope none of you have ever done this. The manager selected a random sample of 80 customers who asked for a water cup when placing an order and found that 23 of those customers filled the cup with a soft drink from the beverage fountain. Can you imagine? They're trying to get a freebie out of the restaurant. They're going for a water cup, pretending that they only want water, but they really want soda from the fountain, which is a form of cheating. Now, I don't know how you feel about this issue, but I feel that the state of New Jersey should definitely crack down on something like this. This is pretty serious. I would never do that. As a matter of fact, most places I go to, you have to buy a drink, and they have the water option, which you can take advantage of and just have the water without having the soft drink. And quite frankly, having some seltzer, maybe with some ice, might be the healthier option, because I will tell you, people, habitually drinking soda is not the healthiest thing to do. Soda is definitely not healthy. As much as it tastes great, it is not a healthy option. It is loaded with sugar. Even fruit juice is loaded with sugar. People now say so. I'm holding off on even getting. I'm trying to cut back on fruit juice. Now, I must say that in my current age, whereupon I did not drink soda for many years. I did have quite an amount of diet soda earlier on, 25 years ago. I quit that. I later realized how bad that stuff is. I mean, that stuff is loaded with chemicals. So you think you're going to save calories by having diet soda? I mean, it's not good. So I have settled down to sparkling flavored seltzer, which is quite delicious, and stems off any need for soda or anything like that. However, I've gotten into kind of a bad thing in that I like very good quality root beer. Not made with that junky corn syrup, but real. It's kind of expensive, but I do like it. I don't know. I will have it occasionally. All right. That being said, which maybe is appropriate for April Fool's Day, construct and interpret a 95% confidence interval for the proportion of all customers who, having asked for a water cup when placing an order, instead cheat and fill the cup with a soft drink from the beverage fountain while the proprietors are not looking. Okay. Now remember, what is the first thing we have to do on this? This is a simple one proportion z-test, but we do have to check something. And when you answer this, you have to have checked the conditions. Now, what were the conditions? It has to be random. Well, we're told it's a random sample of 80. Does the 10% condition hold? Do you think the number of customers is at least 800? I'm going to say that it definitely is. And then we're looking at p hat times 1 minus p hat. N times p hat is 23, which is greater than or equal to 10. N times 1 minus p hat is equal to 57, which is also greater than or equal to 10. So the 10% allows us to use the approximation to the standard deviation of square root of p hat 1 minus p hat divided by 80. And these two conditions, n p hat and n times 1 minus p hat, both being greater than or equal to 10, allow us to use the normal approximation. So we're ready to do the calculation. Now remember, you're not going to do this by hand, you're going to do it by on your calculator, and you are going to make sure to write things out, because you will get partial credit if you write it out and just you do a wrong keystroke or something like that. But remember, we're going to go into the stat key. Whoops. What did I just do? Stat. We're going to go over to tests. Now, this is not the z-test, it's not the t-test, it's not a test, it's a confidence interval. So we're going to skip all of the tests. And it's not a z interval, it's not a t interval, that applies to the means. It's not a two-sample z or t test. It is a one proportion z interval. So we're going to go into that. And this is probably one of the simplest things that you can carry out on your calculator. And I already have it set up. It really just asks you for very minimal information. What is the number of successes? That's 23. What's the sample size? 80. What's the confidence level? 95. So you scroll down, press enter, and it spits it out immediately. So what's going on internally is, I don't know whether the algorithm is actually checking the conditions. That's a good question, but you need to check the conditions. Anyway, let's assume that the algorithm does not check the conditions. I mean, we could test it by putting in an example where the conditions are not met, and I don't want to do that now, but on your own, for the same problem, instead of putting in 80, you could put in, I don't know, a number that would cause n times p hat to be less than 10, see if it spits out an error. I don't know that it would. So just because the algorithm is giving you an answer does not mean the AP is going to be satisfied with that, because they want to see that you know the conditions. So the p hat is a 0.2875 from my notes. You get that. The conditions have already been checked, and it gives us the interval of 0.1183 to 3867, which is here. 0.1183 to 3867. Okay. That answers the first part of the question. The second part of the question is, the manager estimates that each customer who asks for a water cup but fills it with a soft drink costs the restaurant 25 cents. Suppose that in the month of June, 3,000 customers, 3,000 customers ask for a water cup when placing an order. Use a confidence interval constructed in Part A to give an interval estimate for the cost to the restaurant for the month of June from the customers who asked for a water cup but fill the cup with a soft drink. Those mean people. Okay, so we've got here, we're going to use the interval. We got 3,000. This is giving us the interval of the proportions. Here's the number of customers. So we're going to take our 3,000 multiplied by this 1.1883, and the number, the amount of loss is going to be 25 cents. So we're going to multiply those three numbers. We're going to do the same thing over here. Take 3,000 times this times 0.25. I do that over here. Bum. I do that over here. Bum. And numbers come out to 141.225, 290.05, which is approximately $141 and $290. So these culprits are costing the restaurant approximately anywhere from $140 to $300 roughly per month, assuming that 3,000 ask for a water cup. Does it make sense for the restaurant to watch more carefully over the people who ask for a water cup? One thing they might do is say, we don't believe that you're only going to drink water, so we would advise you to have a soft drink. Anyway, our food tastes much better when you accompany it with a soft drink and not simply plain water. So I'm going to stop with that, but I would like you to try number 3 from 2017. And with a little bit of luck, we'll go over it tomorrow. I say a little bit of luck because I am moving today, and I'm going to have to get reset up in my new place. And the Optimum guy is supposed to come over this afternoon and set up my Wi-Fi. Now, normally it wouldn't be a problem because I could go to another, a public place that has Wi-Fi and do it, such as Barnes & Noble. But guess what? The Barnes & Nobles are all shut down. Guess what? You can't congregate in public. Guess what? There probably is no, I don't even know if libraries are open. Huh, good question. I don't think they are, actually. Any place where you have to congregate or would possibly congregate, it seems to be shut down. So I can't guarantee that there will be, well, for the following day, I should be set up. So let's assume that I will be. Anyway, this question says, it's also a straightforward question. Grocery store purchases melons, 2 distributors, J and K. J has melons from organic. Distribution J is approximately normal with mean 133, standard deviation 5. Probability that the melons have a diameter greater than 137, you know how to do that. And then they ask another straightforward question, which combines another type of distributor who just gets melons from non-organic farms. Oh my, non-organics. Here, look at what they put in front of you. First of all, they're talking about people who steal soda, pretending that they're just going to drink water. Secondly, they have distributors who deal with non-organic melons. Ooh, not a good thing. Anyway, give this question a shot, and hopefully we'll go over it tomorrow. Take care. Bye.